Hi friends, welcome back. In the previous session, we were stuck up at deleting a node while using a single linked list and realized that it needs additional work to be done so as to remember the previous node, because we need to link the previous node to the next node. So there has to be an extra variable required to keep saving the previous node at every step. So to solve that problem, we realized that if there was a link which was showing backwards along with the link which is showing in the forward direction, it would be easier, so we don't need to remember anything. So that was the idea of creating a doubly linked list. So when you say doubly linked list, the node has got three components. One component reserved for the data, one component is reserved for the data, and one component, as we have seen in single linked list, reserved for storing the address of the next node. Along with that, we added one more component which stores address of the previous node. So what does that mean is we can look this example and try to understand what we are trying to tell. So there are four nodes here, N1, N2, N3, N4, containing data D1, D2, D3, D4. Now the issue is what is written here. Yeah, there is nothing before this, so written here is a null. So what is written here? Here you have address of N2, node 2, and here we have address of node 1, and here we have address of node 3, here we have address of node 2, here we have address of node 4, whereas here we have address of node 3, and here we don't have anything, so gets blank. So that's how things are arranged. So whenever we are at any given node, say if we are at node N3, so if you want to go backwards, then use the back pointer, and that gets us from N3. If you use back pointer, it leads us to node N2. And if you want to move forward, then use the front pointer, and that leads us to front, says N4. It takes us to fourth node. Done. How all these things are done, let's see in detail one by one. What should I call this? So let me call this node. And how the node is defined? Defined as a structure. There is a space for writing the data. Then there is pointer to the node, which we call it back, and there is a pointer to the node which we call front. So that's an abstract way of defining a node. Done. Then what all operations possible. Create node. Yes, we can create a node and define that with a number, name, n1, n2, n3, or n4, so on. So when you create a node, so structure with 3 places are created. One to save the address to the back node, one to save the data, and one to save the address of the front node. That's so this whole thing is created once you create a node. Then we can add data to any node. So how do you add data to the node? Say node n1 was created and you want to make n1's that's capital D. Okay, n1's data is equal to d1. So that's only list we have, and if you call this by some name list, then your list will be n1's address of n1. Done. Then what is n1's back is null because nothing is there before n1. N1's front is null because nothing is there after n1 because only first node we have inserted. Then you want to insert another node. So insert node means create node, add data, and then connect links appropriately. Okay, now let's assume that we are creating a node for n2. So when node n2 was created, so we get n2 dot data, then we have n2 dot back, then we have n2 dot front. Okay, what all things we need to do? So n2 happens to be here. n2's data we wanted it to be d2. Done. Then n2's back is pointing to n1, so we say should be address of n1. So after n2 nothing is there, so that's going to be null. So one part of the work is done, but the forward part is still missing, so this has to be updated. n1 dot front is address of n2. So n1 dot front will be address of n2. This part was not there in the beginning, now we included. So as of now we have 2 nodes, and n2's front is null because there is nothing ahead of n2, and n1 dot back is also null because there is nothing before n1. Done. What next? What can we do? So that way we assume that d3, d4, n3, n4 are also inserted. So assumed that same way N3, N4 are inserted. Okay, done. What next? So the issue, can we delete a node? Yes, of course we can delete. Which one you want to delete? Say N3. Or you want to say delete a node with data D3. Whatever way you want, you can tell. So what we can do, start from the front, which is called list. So list we have defined as a address of node 1. So that's list. So start with the list, goes to the first node N1, find its value, it is D1, we are looking for D3, no, then go to the next node front, it goes to N2, N2's data is D2, it is not D3 which we are searching for, then proceed further, go forward, and you will reach N3 and whose data is D3. So we have started from front, that is N1, and then went to N2, then went to N3 where we found T3. So this N3 has got two pointers, one showing to the back, one showing to the front. So what we can do is this D3 has to be deleted. That means node N3 should be removed from this linked list. So what is to be done is from N4, if you are moving back, then the next time you should go directly to N2 instead of N3. And from N2, if you are going forward, then because node 3 is no more existing, then you have to directly jump to this. So which only means that we need to correct that. So here we had written N2. Now we have to write the N3. Now we have to write N2. And here we had written N3. Now we have to write N4. From where we get this? In case of single linked list, one forward journey was known to us, but behind node was unknown to us. But now what you want, in the back of N4 you have to write N2, and in the back of N2 you have to write N4. So what is the easiest way? So what do you have in the back of N3? The back of N3 we have address of N2. In the front of N3 we have address of N4, right? So what is to be done? So go to N2, update front. So go to N2, update its front. And when you get N4, then go to N4 and update it back. With what value? N2's front should be updated with N4. N2's front is updated with N4 and N4's back is updated with N2. So where do we have that value? So this you write back of N3 and this you write front of N3. That means in all what we have to do is N2's front will become N3's back, and N4's back will become N3's back. So N4's back will become N2's front. What is there N2's front? Where do you get that? N2's front was there. You want N2. You want N2, which is there at a, so I'm sorry. N3 is back. What was N3's back? It is N2. Where do you want to write? In N4's back. N4's back, you write what was there in N3's back. In N3's back it was N2. Now that N2 you add here the same way. What was there in N3's front, you add in N2's front. N2's front will be N3's front. So by doing this, now where did you get N4? N4 is front of this. So it's in all what you can say is N3's back is talking of N2. N3's back is N2 and its front will be N3's front. Same way, N3's front, whatever it was showing, N3's front it was showing N4, and N4's back should be same as N3's back. And once this is done, then the node N3 should be deleted, or the memory should be deallocated. So we don't need to just worry anything. So this was an example of N3. Now it can be of any situation. So the simple thing is nkth back dot front is to be copied from nkth front. Nkth front shows one node whose back should be updated by nk's back. So this is common for every situation. So any node you want to delete, yes, that's the thing. Yeah, inclusion insertion is not an issue. So if you want to insert any node here, then you just have to create an extra node and then make the necessary connections. So you cancel this from here, connect here, and from here connect here. So that makes forward journey, and then cancel this from here, connect here, and from here connect back here. So that allows you reverse journey. So this way, the fifth node can be inserted between N1 and N2. So insertion is similar to the insertion we did in a single linked list, but only thing is we have to update two links. Yeah, what's the advantage of? Yes, one disadvantage you can think is now we have to maintain two pointers instead of one. So that's going to be an extra burden as far as the space is concerned. But yes, of course, it is going to be a universal type of data structure which can be used for many purposes in coming future. So we just look at all other applications of working with the double linked list. So how they can be useful for creating other data structures. So these things we will be covering in our coming sessions. So keep watching. Thank you.